নাই স্যার শুনি পোৱা নাই স্যার ভালকে স্যার
এতিয়া
স্যার ফাটি ফাটি আহি আছে
এতিয়া
একোৱে
শুনিছা
শুনা পোৱা নাই ছাৰ।
নাই স্যার ফাটি ফাটি আহি আছে
please check your internet connection. Here I am using the LAN connection. Okay, is it too fast? Please check your internet connection. So is it clear now? Little bit clear?
No, sir.
No. Totally not.
নাই স্যার
Totally not.
আপোনাৰ ভইচটো
এতিয়া
ক্লিয়াৰ
শুনা পাইছানে তোমালোকে?
স্যার হেডফোনৰ মিকটো চাগে কিবা আছে চাগে স্যাৰ
এবাৰ আমি কিন্তু you know,
হেডফোনডাল খুলি লওক নেকি?
হেডফোনডাল খুলিলে শুনি পাইছা? এতিয়া শুনা পাইছা?
স্যাৰ এতিয়া আহি আছে স্যাৰ
এতিয়া শুনা পাইছা?
স্যাৰ
এতিয়া পাইছানে শুনা?
স্যাৰ পাই আছো এতিয়া
এতিয়া পাইছানে শুনা?
পাইছো।
পাই আছো এতিয়া
Okay. Listen, I will take your class when you are free. That means you have some self-study portion is also there in your routine. Okay. At that period, I will take your last class, that is practical class. Okay. Tomorrow, is it any self-study period is there? Yes or no?
হাফত আছে স্যার
Huh?
ফার্স্ট হাফত আছে স্যার
Okay. Then I will put your practical class in first half. Fine. I will put practical class in first half. Okay.
ওকে স্যার
So, not wasting our time, I will just start our that means next part of our this preformulation study. Okay. So wait. So, is it have you seen the screen?
yes sir
So your voice is not perfectly audible for me because I am not using the headphone. Okay. Okay. So if you are, if I am audible to you, then you just listen properly. Okay. And I will
yes sir
tell all the things. Okay. From the inside, I will not properly audible your voice. Right. So in the last class, we are discussing about the hygroscopicity. Is not it? Hygroscopicity, we have just in the last class, we are just discussing. Next, discuss with the particle size. Okay. So particle size is also one of the important factor for the preparation of in the formulation of preformulation studies. Okay. So what are the term we are using in the particle size? That is very coarse, moderate coarse, then fine, then very fine. Okay. So particle size is also influenced by various that means important factors. Okay. So these are dissolution rate, suspendability, uniform distribution, then penetrability, then lack of rigidity. So these are the main important factors that is maybe effect on due to the particle size. Okay. In case of cream, if you are going for the preparation of cream, if the particle size of the particular drug of a cream is not in the fine form, then it cannot be that means permeate through your skin. Okay, if it is not permeate through the skin, then it cannot show the effect. Okay, so particle size also the important factor for formulation study. So what is the main that means limitations of the particle size? That is uh, methods of determination of the particle size. First one is the sieving. Okay, we can make the particles in uniform in size with the help of sieving. Have you seen how to make the particles are uniform with the help of sieving? Have you seen it? Yes or no?
Yes, sir.
Okay. Sieving in industrial section, we are using large scale of that means instruments, equipments for increase for the maintenance of particle size. Sieving also is one of the equipment that is called vibrosifter. It is called vibrosifter. That is, with the help of vibration, we are sieving all the materials. Sieving is required for the two cases. What are the two cases? First one is the uniform distribution, uniform particle size, and second one is the what is the second one? Do you have any idea?
Particle size determination.
Porosity of the sieve.
Hmm? Yes, Ambrose.
Porosity of the sieve, I think.
Porosity. Porosity. First one is the particle size distribution. Okay, we are make if we are make the all the ingredients in uniform size, we are going for the sieving. With the help of sieving, we are make the uniform particle size different with by taking different sieves. Okay, that is 20 mesh, 30 mesh, 40 mesh, 100 mesh. Okay, 80 mesh. Okay, so in case of 80 mesh, if we are taking, that is the outcome will be very fine. In case of 100 mesh, then the outcome will be more than fine. Okay, if we are taking 20 mesh, then it is moderately coarse or coarse, or it may be fine. When we are taking 60 mesh, it will fine particles. When we take 20 mesh, you will got the coarse particles, and if we take the 10 mesh, then it is very coarse particles. Okay. So that is a sieving method. Sieving method we are using for the that is to make the particle size in uniform. Okay, and another for another purpose for use of another that means use of sieving, that is to separate the foreign particles from the our materials. In case of calcium, lots of that means uh, other foreign particles are present in case of calcium. Okay, so to separate the calcium, to separate the foreign particles from the calcium, we are using the sieving. Okay, so sieving method have some limitations. Limitations with it can be sieved. We can make the particle size from 5 micron to 150 micron. Okay, for that means in case of if it is less than 5 micron, then we are using the microscopic method for determination of particle size. Okay, so that is the in case of microscopy, that is 0.2 micron to 10 micron. Okay, for sedimentation rate method, it is 1 micron to 200 micron. The particle size in between 1 micron to 200 micron, we can for determining the particle size, we can put sedimentation rate method also. Okay, then 0.5 micron to 500 micron we are using. You can use light energy diffraction. You can use light energy diffraction. Okay, so next that is laser holography. That is laser holography. We can use that is 1.4 micron to 100 micron. Okay, so now you have some confusion that sir told me that that is sieving method, that is 5 micron to 150 micron. Okay, but in case of microscopy, that is 0.2 micron to 100 micron. But those particles who have in between 100 to 150 micron, or that means 50 to 100 micron, you can use both sieving and microscopy. Understood my point? Have you understood my point?
Yes, sir.
Okay. So that means
Yes, sir.
that is the range. That is the range. In between that range, you can use always. That means particle size determination method. Okay. You can use microscopy in case of, that means 0, 0.2 micron to 100 micron. But in case of sieving method, you cannot use those have the particle size 0.2 micron. You cannot use the sieving method. Right. So next come with the powder flow properties. Why powder flow properties is the important parameter for the preformulation study? Do you have any idea? Powder flow properties. Do you have any idea why powder flow properties is an important parameter? What? Nimboy protein setia what? Nimboy what? Anyone? Anyone? Powder flow properties. Why it is important in the preformulation?
So we can't hear you, sir.
You cannot hear me. So why powder flow properties is an important factor in the preformulation study?
For the flow.
Sir, in the preparation of tablets, so we can know if the powdered drug will be compressible or not, or what will be the bioavailability of the drug in the powdered form.
Bioavailability, no, bioavailability is not allowed with the flow properties. Okay? So it is the pre-compression parameter. It's not the that means pharmacokinetic parameter. It is the pre-compression parameter. Okay, it is flow properties is important in the preparation of the formulation. Okay, it is not directly related to the bioavailability. Okay, it is the related. It is related to the preparation, or that means uh, proper formulation of a formulation. Understood? So powder flow properties can be affected by by change in particle size, shape, and density. Yes, it will affect on the viability when it will be go in the systemic circulation. But obviously, it has some relation in between, that means formulation parameters. Okay, formulation parameters means that is particle size, shape, and density. Okay, so powder flow properties is also the important factor for particle size, shape, and density. Okay, the flow properties depends upon following, that is force of friction. Force of friction. Why we are using in the preparation of tablet? We are using magnesium stearate, talc. Why we are using all these excipients? Am I audible to you? Am I audible to you?
Yes, sir.
Yes or no?
Yes, sir.
Yes.
Yes, sir.
So, why that means why we are using magnesium stearate talc in the formulation of tablet?
So force of friction is low.
Yes, it is used as a lubricating agent. So, why we are using lubricating agent? To increase the flow properties of the particular formulation.
Powder.
Okay, powder. In case of powder or granules, when you are going for direct compression, when you are mixing all the ingredients in the proper ratio, then it becomes granules, not in the powder form. It called as a granules. to check the flow properties of the granules. So here we have to add that magnesium stearate and tap. It's nothing. So force of friction. What is the main? That means involvement of force of friction. Why force of friction? We have to make the force of friction less in the preparation of the tablet or any formulation. Why we have to? Why we are saying that the flow properties of the particular powders or particular granules should be in the limit? Why we require the flow properties? Because when you are preparing the tablet or any formulation, in case of tablet, I am giving the example. It sticks on the hopper. It sticks on the hopper. Okay, it sticks on the die. It sticks on the punch. Okay, because we are using the binders, that's why it sticks on the. It maybe sticks on the die, punch, or hopper. Okay, so due to the avoid this kind of that means uh, this kind of characteristics, we have to use the lubricants. So that's why powder flow properties is an important factor in the preformulation study. Okay, so cohesion between one particle to another. Okay, if it is not flow properly, it may be cohese each other. It may be, that means make friction each other. Okay, so that means what? That means the quality of the drug or quality of the granules become degraded. Or not? It's not so. When it collapses each other, then it becomes the fine particles, not in the granules form. Okay. So fine particle causes poor flow, by filling, that means void spaces between large particles, causing cracking and densification of the particles. So fine particles causes poor flow by filling weak spaces between large particles, okay, causing packing and densification of the particles. So to avoid this kind of things, we have to add the that means lubricating agents. Okay. So by how can we increase the flow properties? By using glidant or lubricating agents. So examples are 10. Okay. So how can we determine the powder flow properties? Next one. So you know that you already understood why powder flow properties is an important factor for the preformulation. Now, next question is that how can we determine the powder flow properties? Okay, by calculating the angle of repose. Have you heard the term angle of repose in previously? Angle of repose. Have you heard what is angle of repose? Students, am I audible?
No. Yes, sir. No, sir.
Angle of repose you are never heard.
No, sir.
No. Okay. So angle of repose. How can you calculate the angle of repose? Here, seen that. Have you seen the chart that is angle of repose in degree? Then type of flow. Okay. If the angle of repose is less than 25 degree, then the flow properties we can consider as an excellent. Okay. So the degree of angle of repose in between 25 to 30, then the type of flow is good. Then 30 to 40, it is possible. Okay, if it is the angle of repose more than 40, then it is very good. Now talk about how can we determine the angle of repose. Okay, so and for angle of repose, you require one funnel, one backbone stem, okay, and one plain paper. Okay, so you just put the funnel in the backbone stem. Okay, you just put the funnel in the backbone stem. Then you just keep the drugs in the funnel. Okay. Then drug will flow from the funnel to the surface. Okay. Then it will make a cone shape. A cone shape, that means formation by the drugs. It will fall in down and form a cone shape. Okay. Then you calculate the radius and hypotenuse of that particular point, right? With the help of scale. Okay, so then you have to calculate the particular formula with the help of particular formula. Tan theta is equal to h by r. H means hypotenuse and r means the radius. Okay, so theta is the your angle of repose. Okay, so theta is the angle of repose. H is the height of point. Pi means you are just fall down all the, that means excipients or all, sorry, all the granules from the surface of the, that means surface of the funnel. From the surface of the funnel, it will fall down to the surface, lower surface. Then it will form a pipe. Okay, so the height of the pipe and the radius, with the help of height of the pipe and radius, you can calculate the angle of repose. That is h and r. H is the height of the pipe and r is the radius. Okay, so a greater angle of repose indicates more flow. When the angle of repose, that is theta value. So how can you calculate the theta? Theta is equals to 10 to the power minus 1 into h by r. That is the value of theta. Okay, you can calculate the theta with the help of this formula, that is 10 to the power minus 1 into h by r. Okay, so if the theta value is more than 40, then the angle of repose, that means it shows the very poor properties of the fluid properties. Okay, so when it will be accepted, when it is accepted, when it is in between the range of 2. Okay, that means the angle of repose is less than 30, then we can calculate it that it is acceptable for according to the flow properties. Okay, so this is about the angle of repose. Here you can see. Have you seen the diagram here? You can understand properly. Have you seen the diagram here? Students, have you seen the diagram?
Yes, sir.
Yes.
Yes.
This one what? This one funnel. See, this one funnel. From the funnel, we just put the drugs here. It will fallen down and it will make this pipe. Is not it? Have you seen the triangle here? Have you seen the triangle? In the first
Yes.
see the diagram A. That is a triangle. That is triangle means that is the all the drugs that is fallen. It is looks like a mountain, is not it? It looks like a mountain. Okay, when it is fallen down, it looks like a mountain or it is fallen as a pine. Okay, so this is the radius 2r. See, this is the 2r. 2r is the, that is what? You have to calculate the all the, that is 2r, that is radius. You can calculate the radius by dividing by 2. Okay, this is radius and this is hypotenuse, h. See, this is hypotenuse means this is the height of the pipe. You can calculate with the help of the scale, that is hypotenuse, and radius of that particular surface, particular point. Okay, so with the help of following formula means tan theta is equal to h by r. With the help of that particular formula, you can calculate the angle of repose. So what you have understood now, that angle of repose is, if the angle of repose is less than 30, then we can accept as a good properties of the particular what? Granules. If the angle of repose more than 30, then it will be what? Not accepted. Have you understood this one? Yes or no?
So actually, the diagram,
Hmm?
I didn't understand very well.
Diagram you did not understand.
Yes, sir.
Okay. Okay, don't worry. Next, from the 2 o'clock, you have class of Himanshu sir, isn't it? 2 o'clock, you have class of Himanshu sir, is not it? From 2 o'clock,
I think 3.
3 or 2. From 2 o'clock or 3 o'clock?
So 3 o'clock.
So see, I will show you how can you calculate the angle of repose. So just wait, okay? I will show you.
Yes, sir.
Have you seen this one? Have you seen
Sir,
this one?
Yes, sir.
Okay. This is what? Funnel. This is
Yes, sir.
tripod stand. Okay. Okay. You have to put that all the ingredients in the funnel. Okay. You just first place it here. Then you have to put all the ingredients in funnel. Then it will flow in the downward direction. Okay. Have you seen this one? In the downward direction. So this is the height. This is the height of the hypotenuse. Okay, this is the hypotenuse and this is the circumference. From this circumference, you can calculate the radius. Okay.
Okay. Okay.
Okay. This is the circumference of the
Yeah.
particular granules. Okay. And this is the height. How much height? This one. You can calculate the height with the help of scale. You can calculate the circumference with the help of circumference or with the help of scale. You can calculate the radius. So what is the formula? Formula is the tan theta is equal to h by r. Okay. So theta is your, that means theta is your angle of repose. So theta
Angle.
is equal to 10 to the power minus 1 into h by r. H is the height and r is the radius. Okay. By the help of, by calculating this way, you can calculate the angle of repose. Now understood?
Yes, sir.
Okay. So you just give your attendance. I have another meeting with first semester students. So from 2 p.m. If possible, I will take class again. Okay. So you just give your attendance. You can leave now. Okay.
Okay, sir.
Okay, sir.
Okay.